Good morning, ma'am.
Morning. Can you hear me?
Yes, ma'am.
Yes, ma'am.
Yesterday net went off. So yesterday's video is very small. So we were dealing with oxidation states. Algebraic sum of the oxidation states of all the atoms in a compound in a species is equal to 0. If that species is having a charge, then it is equal to that charge. For example, K1. K1. Algebraic sum of all the oxidation states is equal to 0. Find out the oxidation state of Mn. K plus 1. K is from the first group. First group plus 1. Second group plus 2. 13th group plus 3. 14th group plus 4. 15th group minus 3. 16th group minus 2. 17th group minus 1. So here, 18th group means no more gases, no oxidation. So this is one oxidant that is minus 2. One oxidant that is minus 2. So how will you calculate the oxidant state of Mn? Mn can have variable valency plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Mn can have variable valency. In this compound, what is the valency? What is the oxidant state of Mn? So we'll be calculating plus 1 of potassium and Mn we are writing like that only. There are 4 minus 2. So minus 2 into 4 is equal to 0. So plus 1 plus Mn, we are finding out the oxidant state of Mn. That is minus 8 is equal to 0. Mn minus 7 is equal to 0. Mn is equal to plus 7. So the oxidant state of Mn in K1O4 is plus 7. So in K1O4 there is no charge. There is no charge. The species has no charge. But if I write the same thing, in the form of charge, that is MnO4 minus. MnO4 minus. This means that minus is for this entire species. So now the oxidation state of all the atoms inside that is equal to this charge. This is minus 1. We normally write minus means minus 1. So Mn plus minus 2 into 4 is equal to minus 1. So Mn plus Mn minus 8 is equal to minus 1. Mn is equal to minus 1 plus 8. So Mn plus 7. Same thing. Both are same. K1O4 is same as MnO4 minus. When you put K1O4 in water, you will get K plus and MnO4 minus. These ions will be separated. So Mn means Mn's oxidation state in both, that is same, Mn plus Mn plus. Now let's find out the oxidation state of chromium in potassium dichromate. Chromium in K2Cr2O7. In K2Cr2O7. So here you see K plus 1 oxide minus 2. Total is equal to 0. Total is equal to 0. So plus 1 into 2 plus there are 2 chromiums, 2 Cr plus minus 2 into 7 is equal to 0. This is 2 plus 2 Cr minus 14 is equal to 0. 2 Cr minus 12 is equal to 0. 2 Cr plus 12 or Cr plus 6. So this is the oxidation state of Cr in K2Cr2 in K2Cr2. So for the same species, if I write in this ionic format, that is Cr2O7 2 minus, then sum of the oxygen is equal to that minus 2. Again, the same value you are going to get 2 Cr, this is minus 2 oxygen, single oxygen is minus 2, plus minus 2 into 7 is equal to this charge, that is minus 2. If there is a charge, the total charge, so the sum of the oxygen is equal to that charge. So 2 Cr minus 14 is equal to minus 2. 2 Cr is equal to minus 2 plus 12 plus 14 means plus 12. So Cr is equal to plus 12 upon 2, that is plus 6. So oxidation states of these, whether it is in the neutral species or in the charged species, both are same thing only. Potassium dichromate is same as dichromate ion. We call that as dichromate ion. Potassium permanganate is same as permanganate ion. So that's how we find out the oxidation states of different species in oxidation state of different atoms in different species. Now, write one question. Find the oxidation state of the underlyings. Na2 H2PO4 in this phosphorus P. P का oxide state you have to find out in the same method. Na plus 1, H plus 1, O minus 1. Next. Answer you will be getting as plus 5. Answer you will be getting as plus 5. Next. NaHSO4. You have to find out S. You find it. And check the answer. S bar plus 6. Plus 6. Then H2S2O7. You have to find out letter S. H2S2O7. You have to find out for S. S. You will get it as plus. K, AN, SO4 twice. Right, CaO2. Ca, we You will be getting it as +2. CaO2. Find out that of O. CaO2. Find out that of O. You will be getting as -1 peroxide linkage. K2MnO4. Find out that of M. You will be getting it as +6. So you find out, so you can calculate of the oxides. Ca +2, here it is Ca, but here it is O2. Ca is always +2. Next, H2SO5. Calculate this oxygen state of S. You know that X is +1, O is -2. So, +1 into 2 plus sulfur plus -2 into 5 is equal to 0. That is 2 plus S minus 10 is equal to 0. S minus 8 is equal to 0. S is equal to +8. You are getting it as S is equal to +8. ध्यान रखना S का maximum oxygen state can be +6 because only 6 electrons are there in the outermost. जितना है उतना ही दे सकते, उससे ज़्यादा नहीं दे सकते. So sulfur has got only 6 electrons, 16th group. So 6 electrons in the outermost shell. It can give only 6 electrons. Here it is said that +8. So this is wrong. This is wrong. We call it as a fall. This is a fall or fallacy. This is a fallacy. Now, how can you remove this fall? How can you remove this fallacy? That is done by considering its structure. By considering its structure. Considering its structure means S double bond O H O H. This is the structure. So you see there is peroxide linkage -1. So two oxygens are under peroxide linkage. That means you cannot take all the oxygens 1, 2, 3, 4, 5, all the oxygens with -2. Only 4 oxygens. This is -2, this is -2, this is -2, this is -1, this is -1. H is +1, H is +1, so sulfur will be +6. See, -2, -2, -4, -4, -6, -7, -8, -8, -7, -6, so S will be +6. So S will be +6. Algebraic sum of all the oxygens will be equal to 0. So how can you count for the fallacy? How can you count for the fallacy? By considering its structure. By taking the structure, you have to explain there is peroxide linkage, so two oxygens are under -1. Next question. Find the oxidation state of N in HNO3 and count for the fallacy if any. Find the oxidation state of N in HNO3. Find the oxygen state of N in HNO3 and count for the fallacy if any. Nitrogen has got 5 electrons in the outermost shell. It can give maximum 5 electrons. It is a 15th group. So max outermost shell contains 5 electrons. It can give maximum 5 electrons. If you are calculating and getting the answer, oxygen state of N as 6, 7, 8, then it is a fallacy. If it is 5, it is okay and it is normal, correct? So let's find it. It is equal to 0. This is plus 1, this is minus 2. So plus 1 plus 9 plus minus 2 into 3 is equal to 0. That is 1 plus n minus 6 is equal to 0. N minus 5 is equal to 0. N is equal to plus 5. There is no fall in, there is no fallacy. This is correct. Nitrogen can give plus 5 electrons. If it comes as plus 6 or plus 7, then it is a problem. Now there is no fallacy. Next question. Find the oxidation state of Cr in CrO5. Find the oxidation state of Cr in CrO5 and count for the fallacy if any. And count for the fallacy if any. Chromium maximum electrons in the outermost shell. Chromium 24. 24 means 85 minus 1. 85 minus 1. Maximum it can give, that is 3D and 4s are almost same energy. 1 electron can 4s can go plus 5 electrons. So maximum oxygen state chromium can show is plus 6. Plus 6. Let's see. Let's find out. That is minus 2. Cr plus minus 2 into 5 is equal to 0. Cr minus 10 is equal to 0. Cr plus 10. Not possible. This is not possible. So we are going for the structure. To count for the fallacy, we are going for the structure. Means all structures you cannot by heart what is given in your syllabus, only those things we are here to do. So Cr, O, this O. The structure is like this, just like a butterfly. The structure is like this. So this is minus 1, minus 1, minus 1, minus 1. Peroxide here, this is minus 2. So minus 1, minus 2, minus 3, minus 4, minus 6. So chromium will be plus 6. So chromium, by taking the structure, we are counting for the fallacy. Next, we are moving to types of redox reaction. Types of redox reaction. Types of redox reaction. Number 1, combination reaction. Means two elements combine to form a compound. Here the condition is that there should be change in the oxidation state of one element on the reactant side and product side. There should be some change in the oxidation state. So in combination reaction, at least one element at the reactant side, one of the reactant should be in the elemental form. One of the reactant should be in the elemental form. For example, C plus O2 gives CO2. It is a combination reaction. C plus O2, carbon and oxygen, combine to form carbon dioxide. This is a combination reaction. So number 1, combination reaction. condition, at least one of the reactants should be in the elemental form. Here both are in the elemental form. So here 0, elemental form means 0, 0. This is minus 2, this is plus 4. So at least one of the, by the condition, at least one of the reactants should be in the elemental form. Number 2, decomposition reaction. Number 2, decomposition reaction. Means one thing is getting decomposed. Here, at least one of the products should be in the elemental form. One of the product, at least one of the product should be in the elemental form means elemental form is 0. So here 2H2O gives 2H2 plus 4. Here it is minus 2. Here it is plus 1. Here 0, 0. At least then only there is a change. There should be a change in the oxidation status. So then only we can call it as redox reaction. There should be a change. So at least one of the product should be in the elemental form. You consider this decomposition. This is CaCO3 decomposes to CaO and CO2. See here, this is plus 2, minus 2, carbon plus 4, minus 2 plus 2, minus 2 plus 4. No change. Reactant side you check any, product side you check any, no change in the oxidation state. That means that is not a redox reaction. We are learning under redox category. Under redox category. So for the decomposition reaction, at least one of the products should be in the elemental stage. Next is displacement. Number 3, displacement reaction. Displacement, metal displacement and non-metal displacement. Displacement reaction under redox category. Displacement reaction. Metal displacement, for example, iron nail put in copper sulfate solution. A metal displacement. So what happens? Metal is displaced, copper is displaced, or zinc put in copper sulfate. Metal is displaced. B. This is a redox reaction. It comes under redox category only. Non-metal displaced. Non-metal displacement. When you put metallic sodium in water, it caught fire. Na in water, it got fire. Due to the formation of this H2, it's an exothermic reaction. The H2 is catching fire, and see, hydrogen, non-metal is displaced. Non-metal is displaced. This happens in cold water, as we studied last year. Cold water. Some metals, that is Mg, with the steam, hot water. Mg plus H2 gives MgOH2 and H2. So here, this is hot water or steam. With steam, the reaction goes faster. With hot water also this can be done. But some cannot even react with the steam. So for them, we have to put acid. For example, zinc. Zinc plus HCl to liberate that non-metal. Zinc plus HCl gives ZnCl2 plus H. So this is with acid. Fe can also react with steam to form Fe2O3 and H2. Fe2O3 and H2. But the reaction is very slow. But Fe can easily release hydrogen with HCl. So that is non-metal displacement. In the case of halogens also, this non-metal displacement is applicable. Just like the electrochemical series, we can make a series for halogens, that is fluorine can make chlorine, yes, chlorine can make F2 plus KCl gives F2 plus KCl, 2 KCl. F2 plus 2 KCl gives Cl2 plus 2KF. 2KF means F2 can make Cl2. F2 plus 2KCl gives 2KF plus Cl2. Similarly, Cl2 plus 2KBr. Cl2 can make F2 can make Br also. F2 can make Cl2, F2 can make Br2, F2 can make I2. Means upper one can make lower one. Cl2 can produce Br2, Br2 can produce I2. Br2 can produce Cl2 can produce Br2, Cl can produce I2 also. Br2 can produce only I2. So 2KCl plus Br2. See, Cl2 is making Br2. Now Br2 can make I2. Br2 can make I2. That is 2KBr plus I2. My point is, upper one can make lower one. F2 can make Cl2, Br2, I2. Cl2 can make Br2, I2. Br2 can make only I2. Upper one can make lower one. That is, this is again non-metal displacement. Next reaction is disproportionation reaction under redox category. Then we will do it in the next.